Solution of the differential equation dy by dx equals y minus x upon y plus x is. So given differential equation is dy by dx equals y minus x upon y plus x. We are supposed to find the solution for this. So again this is an implicit function. So we substitute y equals vx. So therefore dy by dx will be v plus x dv by dx. So we substitute this here. So dy by dx will be v plus x dv by dx equals vx minus x upon vx plus x. Taking x common, get x into v minus 1 upon x into v plus 1. That is equal to v minus 1 upon v plus 1. So we shift this term to RHS. So this will be minus v and this is x dv by dx. We simplify this term, we get minus of v square plus 1 by v plus 1 and this is equal to x dv by dx. So bringing x terms on one side and v terms on other side, we get v plus 1 by v square plus 1 dv equals minus 1 by x dx. Integrating both sides, we get now when we take v square plus 1 equals t, so derivating this we get 2v equals dt. So substituting using substitution technique, we can write this as t by so v will be dt by 2. So this will be v plus 1 is v plus 1 will be okay. We can split this term into v by v square plus 1. We'll solve it separately. So what we got previously was integration of 2 by integration of v plus 1 divided by v square plus 1 dv is equal to minus integration of 1 by x dx. So we can split this term as integration of v by v square plus 1 dv plus integration of 1 by v square plus 1 dv equals integration of minus 1 by x dx. So now here for this, when we put v square plus 1 equals t, so 2v will be equal to dt. Therefore v will be dt by 2. So substituting this here, v square plus 1 is t, so 1 by t, and v is dt by 2. So this will be dt by 2. So integration of this term will be, so this term is simplified as integration of half 1 by 2t dt. So integration of 1 by t is log t and this is constant. But t is v square plus 1, so this will be half log v square plus 1. So we simplified this term. Now integration of 1 by v square plus 1 is tan inverse of minus v, tan inverse of v for this term. This is a standard formula. So for this we got half log v square plus 1. For this we got tan inverse of v, and for this we get log of minus log of x, that is. So after integration we get half log of v square plus 1 plus tan inverse of v plus a constant, integration constant, let's say c1. This is equal to minus of log x. So now we multiply it throughout by 2. This will be log of v square plus 1 plus 2 tan inverse of v plus 2c1. This will be equal to minus 2 log x. So we can add these two terms. So we can write, bringing this term to LHS, we'll get log of, let's say this can be written as log of x square. Similarly, this can be written as we'll simply add this and this. Log terms will combine it, so we'll get log of x square. When we switch this to LHS, log of x square. So this is x square, log of x square plus log of v square plus 1 plus 2 tan inverse of v plus 2c1 equals 0. So by law of logarithm, log of a plus b is log of ab. This will be log of x square into, now we resubstitute v equals y by x. We convert everything in terms of y and x. So v will be y by x. So this is y square by x square plus 1 plus, similarly this will be 2 tan inverse of y by x plus 2c1 equals 0. Let this constant be c. So now here when we cross multiply, we get y square plus x square by x square, and x square term gets cancelled. We are left with log of x square plus y square plus 2 tan inverse of y by x, and this constant is c, so this will be equal to 0. So comparing it with the options, so answer will be c, 2 tan inverse of x, log of x square plus y square, and a constant c. So the answer is a, log of x square plus y square plus 2 tan inverse of y by x plus c. The question is the order of the differential equation whose general solution is given by y is c1 e raised to 2x plus c2 plus c3 e raised to x plus c4 sine of x plus c5. So what we are supposed to find is order of this differential equation. So what we'll be doing is, first we'll expand the term sine of x plus c5 and we'll simplify it further. So the number of arbitrary constant which we'll be getting from the equation will be equal to the order of differential equation. Since the number of arbitrary constants is equal to the number of times differentiation is made. So it is given that y c1 e raised to 2x plus c2 plus c3 e raised to x plus c4 sine of x plus c5. This is given. So now we can write this as c1 e raised to 2x plus c2 is by law of indices. This can be written as e raised to 2x into e raised to c2 plus c3 e raised to x plus, now this is sine of a plus b rule. So this will be sine a cos b cos a sine b. That is c4 into sine x cos c5 plus cos c5 cos x sine c5. Again simplifying this, now we substitute all the constants. This is a constant, this is a constant, here c3 is a constant, here c4 is a constant. First we'll split this. So this will be c1 e raised to c2 e raised to 2x plus c3 e raised to x plus c4 sin x cos c5 plus c4 sin c5 cos x. So here in this term, this is a constant, this is a constant here, this is a constant, and here this is a constant. So we replace all the constants with some letter a, b, c, d. So this will be a e raised to 2x plus b e raised to x plus c sin x plus d cos x. So we replace these terms with some arbitrary constants. So now we can see number of arbitrary constants is equal to 4. So therefore order must be 4. Since the equation is differentiated 4 times, we got 4 arbitrary constants. So the order must be 4. So the answer is B, 4. In this question, we have to the given differential equation is d2y by dx square equals root of 1 plus dy by dx the whole square. We have to find the order and degree of the differential equation. So given is d2y by dx square double derivative of y equals root of 1 plus dy by dx the whole square. Squaring both sides will be getting d2y by dx square equals 1 plus dy by dx the whole square. So now order of differentiation is, now since it is differentiated twice, so there is a term d2y by dx square, so order will be 2. Order of differentiation is 2, that is the number of times the equation is differentiated, which is 2, and degree of the differential equation is the power of the highest order, that is power of d2y by dx square, which is 2. So this will be 2. So order is 2, degree is 2. So the answer is C, 2, 2. The order of the differential equation y into dy by dx minus x dy by dx plus dy by dx the whole cube is, so here order is 1. Since the highest number of differentiation is 1, that is dy by dx, so the equation was differentiated just once, so the order will be 1. So the answer is A, 1. Degree of the given differential equation d2y by dx square the whole cube equals 1 plus dy by dx and raised to half. So we have to find the degree. So we'll take square on both sides to remove this raised to half. So given is d2y by dx square cube equals 1 plus dy by dx raised to half. Taking square on both sides, we'll be getting d2y by dx square raised to 6 equals 1 plus dy by dx. Now we can see here order of derivative is 2, since the equation is differentiated twice, and the power of this order is, power of the highest order is 6, so degree will be 6. So the answer is D, 6. The order and degree of the differential equation d2y by dx square plus dy by dx raised to 1 by 3 plus x raised to 1 by 4 is, so first we'll separate this term from the equation since the power is a fraction. So given is d2y by dx square plus dy by dx raised to 1 by 3 plus x raised to 1 by 4 equals 0. So we separate this by bringing it to RHS. So this will be d2y by dx square plus x raised to 1 by 4 equals minus of dy by dx raised to 1 by 3. So taking cube on both sides, we can say d2y by dx square plus x raised to 1 by 4 raised to 3 is equal to minus dy by dx. So from here we can see the highest order of the differential equation is 2, and so the degree will be the power of this order, that is 3. So order and degree will be 2, 3 respectively, which is option A. The order and degree of the differential equation P equals 1 plus dy by dx the whole square, the whole raised to 3 by 2 divided by d2y by dx square. So I'll simplify this. We'll bring this term to LHS. We are supposed to find order and degree. So first we'll remove this fractional power. So we bring this to LHS. So this will be P into d2y by dx square equals 1 plus dy by dx square raised to 3 by 2. Now we square both sides to remove the fraction, that is 1 by 2. This will be P d2y by dx square the whole square equals 1 plus dy by dx whole square the whole cube. So the order of the differential equation is, now the highest order of derivative is 2, that is d2y by dx square, so order is 2, and degree will be the power of the highest order of the derivative, that is power of d2y by dx square, which is 2. So degree is 2 power of 2, so the answer is A, 2, 2. The degree of the differential equation y of x is equal to 1 plus dy by dx plus 1 by 1 into 2 into dy by dx the whole square, and so on. So we are supposed to find the degree of this equation. So firstly, since dy by dx is repeated, we'll be substituting this as t equals dy by dx. So we'll be substituting t as dy by dx. So y will be 1 plus t plus t square by 1 into 2 plus t cube by 1 into 2 into 3, and so on. Now this is nothing but 2 factorial, this is nothing but 3 factorial, and this can be said as 1 factorial. So we sense a pattern here. This is in the form of 1 by 1 plus t by 1 factorial plus t square by 2 factorial plus t cube by 3 factorial up to infinity. So this is equal to, this is the form for e raised to x, that is e raised to t. So y is e raised to t. So therefore t will be log y. So since t is log y, we can write this as, now t was dy by dx, so log y must be equal to dy by dx. So here the highest order of the derivative differential equation is 1, and the power of this order is 1, so the degree is also 1. So order is 1, therefore degree is also 1, since the power of dy by dx is 1. The order and degree of the differential equation 1 plus 3 dy by dx raised to 2 by 3 equals 4 into d3y by dx cube is, so given equation is 1 plus 3 dy by dx raised to 2 by 3 equals 4 d3y by dx cube. So we take cube on both sides to remove the fractional 1 by 3, that is 1 by 3 dy by dx square equals 4 d3y by dx square, d3y by dx cube raised to 3. So here we can see the order is 3, since the highest order is d3y by dx cube, that is the equation is differentiated thrice, and the power of this order is, this highest order of derivative is 3, so the degree is 3. The power is 3, order is 3, highest order of the derivative is 3, and the degree is 3. So the answer is C, 3 comma 3. Which of the following differential equation has the same order and degree? So we'll be checking each option one by one. So for option A, d4y by dx raised to 4 plus 8 into dy by dx raised to 6 plus 5y equals e raised to x. So here for 1, order is 4. Order is 4 since the highest power of derivative is 4, and degree is 1 since this raised to 1 is the degree. For 2 we can say the highest order of derivative is 3, hence the degree is 4. So this is not same. Option 1 is eliminated, option 2 is also eliminated. Let's check 3. Option C. So 1 plus dy by dx cube raised to 2 by 3 equals 4 into d3y by dx cube. So we cube these terms to remove 1 by 3 power. So this will be 1 plus dy by dx cube raised to 2 equals 4 into d3y by dx cube raised to 3. Now here we can see highest order of derivative is 3, and the degree, which is the power of this derivative, is also 3. So here both the degree and the order is the same. So the answer is C, 1 plus dy by dx cube raised to 2 by 3 equals 4 d3y by dx cube. The order, we have to find the order and degree of the differential equation given is d2y by dx cube, d2y by dx square raised to 3 plus dy by dx raised to 4 minus xy equals 0. So here the highest order of the derivative is 2, and the power of this order is 3. So the answer is order is 3 and degree and order is 2 and degree is 3. So the answer is D, 2 and 3. The order and degree of the differential equation y equals x dy by dx plus 2 by dy by dx is. So first we multiply throughout by dy by dx to remove this from the denominator. So this will be y dy by dx equals x into dy by dx the whole square plus 2. So here order is the order of the highest order of the derivative is 1, and the degree, which is the power of the highest order, which is 2, is degree is 2, highest power is 2 since. So order is 1 and degree is 2. So the answer is A, 1 comma 2. The differential equation for all the straight lines which are at a unit distance from the origin is, so for we have to find the differential equation of straight lines, the equation of straight lines which are at a unit distance, that is distance from the origin is 1. So the equation of pair of lines, equation of lines whose distance from the origin is unit, that is 1, is given by x cos A plus y sin A equals 1, where 1 is the distance from the origin. So this is the given, this is the equation which is given. So first we differentiated with respect to x. So we get cos A, differentiation of x is 1 plus sin A as it is dy by dx equals 0. So this is first derivative, that is we can say, now let this be equation 1. Now we substitute cos A with sin A. So from here we can say cos A equals 1 minus y sin A upon x. So we substitute this in equation 1. So cos A will be 1 minus y sin A by x. It's the same thing, plus sin A dy by dx equals 0. Multiplying throughout by x, we get 1 minus y sin A plus x sin A dy by dx equals 0. That is taking sin A common and taking this term to RHS, sin A, or we can take this term to RHS. So this will be sin A taking this common. Now, since this term is going to RHS, the signs will change. This will become negative and this will become positive. So this will be y minus x dy by dx, and this will be 1. So taking sin A to RHS, this will be y minus x dy by dx equals 1 by sin A. Now 1 by sin A is nothing but cosec A. So let this be equation 2. So what we had so far is y minus x dy by dx equals cosec A. Now we have to remove this cosec A term and replace it with something else. So we get a differential equation. So this was equation 2. Now what from equation 1? Equation 1 was cos A plus dy by dx sin A equals 0. This is what we got when we derivated the equation for the first time. So rearranging this term, taking cos A to RHS, so this will be dy by dx equals cos A minus cos A by sin A. Now, cos A by sin A is cot A, so this will be minus cot A. So let this be equation 3. Now we know that cosec square x is 1 plus cot square x. So we'll be using this formula here. So cosec square A equals 1 plus cot square A. Now square of this term is again cot square A. So we'll be substituting the values. We get 1 plus, this is dy by dx. So cot A is 1 by dy by dx square equals y minus x dy by dx the whole square. Now let's compare it with the options. So what we have here is y minus x dy by dx the whole square and 1 plus dy by dx the whole square, which is option C. The elimination of the arbitrary constant m from the equation y equals e raised to mx gives the differential equation. So we have to form a differential equation from y equals e raised to mx while removing the constant m. So what we'll do is we'll form an expression in terms of x which will be equal to m. So we'll write m in terms of x, that is. So first we write the given equation y equals e raised to mx. Therefore log y will be mx. So therefore m will be log y by x. Let this be one equation. So this is equation 1. We got m in terms of x and log y. So we can remove m. Again y equals e raised to mx. Now we differentiate this to get a differential equation. So dy by dx equals m e raised to mx. Now we know that m is log y by x, so this will be log y by x into, now e raised to mx is y, so we'll write this as y. So this term is y. So we got dy by dx equals y by x log y. So we'll check the options. Y by x. So dy by dx, y by x log y. So this will be option A. The differential equation of circles which passes through the origin whose center line lies on y-axis is. So what is given is there's a circle which passes through the origin and the center lies on y-axis. So the equation will be given by x square plus y square minus 2ay equals 0. So this will be the equation which we want. Now we derivate it with respect to x. So this will be 2x plus 2y dy by dx plus 2a dy by dx equals 0. That is 2a will be 2y plus 2x dx by dy. That is we divided by dx by dy. Dividing throughout by dx by dy, we got this. So from this equation we can remove 2a, that is from this we can get 2ay will be equal to x square plus y square. Therefore 2a will be equal to x square plus y square by y. So we substitute this here. So this will be x square plus y square by y equals 2y plus 2x dx by dy. So taking all the terms on one side, we'll be getting, and multiplying throughout by y, we'll get x square plus y square minus x square plus y square minus 2 y into y into y, that is 2y square minus 2x into y dx by dy. This will be equal to 0. Now x square plus y square minus 2y square so this can be simplified as x square minus y square into dy by dx minus 2xy. This will be equal to 0. When simplifying this, we'll get this equation. So the answer is A, x square minus y square dy by dx minus 2xy equals 0. Family of curves y equals e raised to x, a cos x plus b sin x represents the differential equation. So the given equation is y equals e raised to x, a cos x plus, taking e raised to x inside the bracket, so e raised to x, b sin x. So this equation is given. We are supposed to find the differential equation. So differentiating this with respect to x, so dy by dx equals, using u into v rule, this will be a e raised to x cos x, differentiation of e raised to x is e raised to x, minus the derivative of cos x is minus sin x, minus a e raised to x sin x. Similarly for this term, this will be plus e raised to x b sin x plus b e raised to x cos x. Let this be equation 1, let this be equation 2. So now simplifying this, we can say dy by dx equals a plus b into e raised to x cos x, taking e raised to x cos x, collecting e raised to x cos x terms, plus b minus a e raised to x sin x. So we took e raised to x cos x and e raised to x sin x terms together. So again differentiating the second time, since in the option it is given in the form of second order derivative. So we derivate this again. So this will be d2y by dx square equals, again this will be similar to the previous sum except there will be two constants. So this will be a plus b e raised to x cos x minus e raised to x sin x into a plus b minus a into a plus b minus a e raised to x sin x plus b minus a e raised to x cos x. So simplifying this, we'll be getting d2y by dx square equals 2b e raised to x cos x minus 2a e raised to x sin x. Now from equation 1 and 2, the terms which are common are a e raised to x cos x, a e raised to x cos x, and e raised to x b sin x, and here it is e raised to x b sin x. So we can say b minus a, that is equal to b e raised to x cos x minus b e raised to x sin x, a e raised to x sin x, this will be equal to dy by dx minus y. Since dy by dx has 4 terms, and out of these terms 2 terms are already in y, so when we remove these terms from dy by dx, which is equal to y, so we'll be getting this term b e raised to x cos x minus a e raised to x sin x. So this will be dy by dx minus y. So we can see here it is, when we take 2 common, we get this form. So this is equal to 2 times b e raised to x cos x minus a e raised to x sin x when we take 2 common. So we convert this arbitrary constant into a derivative form, that is dy by dx minus y. So therefore we got so this is into 2. Again I'll explain it. d2y by dx square is 2b e raised to x cos x minus 2a e raised to x sin x. We got this by simplifying this expression. So when we took 2 common, we got b e raised to x cos x minus a e raised to x sin x. So here when we subtract dy by dx, when we subtract y from dy by dx, we'll be getting this term. Since there are 4 terms, and out of these terms y is present, that is e raised to x a cos x plus e raised to x b sin x. So we'll be getting b e raised to x cos x minus a e raised to x sin x, which is what we want. So we got this term and replace this with 2 times dy by dx minus y. So we got a differential equation which was d2y by dx square equals 2 times dy by dx minus y, which is equal to d2y by dx square equals 2 dy by dx minus 2y, which is option B. If y equals ax raised to n plus 1 plus bx raised to minus n, then x square d2y by dx square is equal to, so first we have to find the differential equation for this equation y equals ax raised to n plus 1 plus bx raised to minus n. So first we rewrite the equation y equals ax raised to n plus 1 plus bx raised to minus n. So differentiating this with respect to x, so dy by dx equals a into n plus 1 into x raised to n plus 1 minus 1, that is n, plus minus n bx raised to n minus 1. So again differentiating, we get d2y by dx square equals a into n plus 1 into x raised to n minus 1 minus n minus n minus 1 b x raised to minus n minus 2. So simplifying this and multiplying throughout by x square, we get x square. Since we are required to have x square alongside d2y by dx square, so we multiplied throughout by x square d2y by dx square equals an n plus 1. This will be x raised to n minus 1 plus 2. So minus 1 plus 2 is plus 1. So this will be x raised to n plus 1 plus minus into minus is plus. So this will be n into n plus 1 into b x raised to minus n, since minus 2 plus 2 is 0. So we have to substitute this arbitrary constants in terms of y. So what we have is first we take n plus 1 common, n into n plus 1 common, this term common. So we get n into n plus 1 into ax raised to n plus 1 plus bx raised to minus n, with this is equal to x square d2y by dx square. So we took this common. Now this term is equal to y. This is what was given. Y equals ax raised to n plus 1 plus bx raised to minus n. So we substitute this as y. So this will be n into n plus 1 into y, which is equal to x square d2y by dx square. So the answer is b, n into n plus 1 plus y. N into n plus 1 into y. The differential equation satisfied by the family of curves y equals ax into cos of 1 by x plus b, where a and b are parameters is. So we are supposed to find the differential equation from the equation of curve. So what is given is y equals ax cos of 1 by x plus b. So now we differentiate this with respect to x. So dy by dx will be equal to a into, since a is a constant, 1 by x plus b minus u into v rule, that is for this one, minus x sine of 1 by x plus b into derivative 1 by x, that is minus 1 by x square. That is equal to x get cancelled. This will be a into cos of 1 by x plus b, minus into minus is plus, so plus 1 by x sine of 1 by x plus b. Again differentiating this with respect to x, so d2y by dx square will be equal to minus a by x cube cos of 1 by x plus b. Again, after simplifying this, we will finally get this term after differentiating these two. So this is what we got after differentiating this. Now multiplying and dividing by x, so we get minus ax upon x raised to 4 into cos of 1 by x plus b. Now we have y equals ax into cos of 1 by x plus b. So what we have is ax into cos of 1 by x plus b. So we can replace this term with y. So this will be minus y by x raised to 4. So d2y by dx square, that is equal to y2, is equal to minus y by x raised to 4. So taking these terms to LHS, this will be y2 x raised to 4 plus y equals 0. So the answer is b, y2 x raised to 4 plus y equals 0. The differential equation when the solution is y equals a sin x plus b cos x is. So given equation is y equals a sin x plus b cos x. Now since in the options it is given in terms of double derivative, we will derivate it twice. So first derivation, that is dy by dx, will be, first derivative will be a cos x minus b sin x. Again differentiating, we get d2y by dx square. Derivative of cos x is minus sin x, so minus a sin x minus b cos x. So taking minus sign common, we'll get minus of a sin x plus b cos x. This is equal to d2y by dx square. But y equals a sin x plus b cos x, a sin x plus b cos x. So this is equal to y. So d2y by dx square is equal to minus y. So taking this term to LHS, we'll get d2y by dx square plus y equals 0, which is option A. The next question is the degree and order of the differential equation of the family of all the parabolas whose axis is x-axis respectively are. So what is given is, we are supposed to find the equation of the family of parabolas whose axis lies on x-axis. That is, it must be something like this, or when h is 0, like this. So the general equation will be y square equals plus or minus 4 into a into x minus h. For this, it is y square equals 4ax, where h is 0. So this is also a part of this equation. So general form is y square equals plus or minus 4a x minus h. So we got the general equation, that is the main solution equation. So we'll differentiate this with respect to x. So this will be 2 into y into y1. y1 is nothing but dy by dx, which is equal to plus or minus differentiation of x minus x is 1, x minus h is 1. So this will be plus or minus 4a. Simplifying this, we'll get 2 y1 equals plus or minus 2a. So again differentiating this with respect to x, we get, using u into v rule for this one, this will be y1 square plus y2 equals 0, since this is a constant. So here we can see the order is 2, since there is a second order derivative. So order is 2 and the power of this derivative is 1. So the degree is 1. So the answer is A, 2, 1. They have asked in the order degree, order. So degree is 1 and order is 2. So it is 1, 2. Since they have asked in the order degree, order. So this is the arrangement. So the answer will be B, 1, 2. The differential equation of the family of parabolas with focus at the origin and x-axis as the axis is. So condition is given as origin acts as focus and axis of parabola is x-axis. So we have to find the equation. First we have to find the equation of family of parabolas satisfying this condition. So this will be, this is given as y square equals 4a into x plus a. So this is the given equation. We have to find the differential equation for this one. So differentiating this with respect to x, we get 2 into y by 1, where y1 is dy by dx, equals 4a. Since derivative of x plus 1 is 1, x plus a is 1. Again differentiating again, so we got 4a as 2y1. That is y1 will be equal to 2a. So let this be 1, let this be 2. So we substitute 1 and 2 in the main equation. That is, we'll be substituting the constants with differential functions. So this will be y square equals 4 is 2y by 1. So 2y by 1 into x plus, now a is y1 by 2 equals a. So this will be x plus y by 1 by 2. So multiplying throughout by 2 and rearranging it, we get y equals 2xy1 plus y1 square. So that is writing this in long form. This will be y is equal to y into, sorry, so this will be y equals 2x into y1 is dy by dx plus y into y1 square is dy by dx the whole square. So if we compare with the options, it matches with B. We just have to shuffle it. So we bring this to LHS and bring this to RHS. So this will be minus y dy by dx the whole square equals 2x dy by dx, and this will turn negative, so minus y, which matches with the option B. Family of curves y equals ax plus a cube is represented by the differential equation of degree dash. So to convert this into a differential equation form, we have to substitute a in terms of either x or y. So y given as y equals ax plus a cube. So differentiating this with respect to x, we get dy by dx equals a. Since this is a constant, so this will be, differentiation will be 0 and this will be a into 1. So dy by dx is a. So we replace a with dy by dx. So y will be x dy by dx plus dy by dx raised to 3. Now if we see the order of the differentiation, differential equation is 1. Since the highest order is 1, first order derivative, and the power of this is 3, so the degree will be 3. So the answer is A. Degree of the equation is 3. The differential equation of y equals ae raised to b, a raised to bx is, so to get the differential equation, we have to substitute a and b with a differential form of x or y. So what is given is y equals ae raised to bx. So differentiating with respect to x, we get dy by dx equals a into derivative of e raised to bx is b into e raised to bx. So rearranging this, so this will be dy by dx equals b into a raised to bx. Now a raised to bx is nothing but y. So dy by dx will be b into y. So let this be, say, 1. So again differentiating with respect to x, we get d2y by dx square will be b into derivative of y as dy by dx. So if we compare this with the options, the dy by dx term is given in terms of power of 2. So here there is only dy by dx of power 1. So but we have v. So if we multiply y on both sides, we'll be getting by, and therefore we'll be getting another dy by dx. So multiplying both sides by y, so this will be y d2y by dx square equals by into dy by dx. So now we got 2 dy by dx, which will give us dy by dx raised to 2. So by is nothing but dy by dx from 1. So this will be y equals y into d2y by dx square, and this will be dy by dx the whole square. So shifting the terms, we get y d2y by dx square minus dy by dx the whole square is equal to 0, which is option D. This will be option A. Y d2y by dx square minus dy by dx the whole square equals 0. Now here again we have to find the differential equation for the solution. Y equals a plus b by x. So given is y equals a plus b by x. So first step is differentiation with respect to x. So this will be dy by dx. A is a constant, so this will be 0, plus differentiation of b into 1 by x is b into minus 1 by x square. So b into minus 1 by x square. Again differentiating this with respect to x. So this will be into d2y by dx square into differentiation of minus 1 by x is the same as minus of x raised to minus 2. So differentiation will be minus 2 into x raised to minus 3. So minus into minus will be plus. So differentiation of this term will be 2b upon x cube. Now we split this into x square and x and shift this term to d2y by dx square. So this will be x into d2y by dx square, and this will be equal to 2b by x square. The reason we did this is because in the options d2y by dx square is associated with x square in some of the options. So we have x or x square. So we choose x for comparison. So we put x alongside d2y by dx square and x square alongside b. So dy by dx, from this we got dy by dx is minus b by x square. So this is what we got. So if you notice, here we have b by x square. This is what we wanted. So that's why we put x along x in the LHS and we got b by x square. But b by x square is minus or dy by dx. So we substitute this as minus 2 dy by dx. And this is x into d2y by dx square. So shifting this to LHS, this will be x into d2y by dx square plus 2 into dy by dx equals 0, which is option B. X into d2y by dx square plus 2 into dy by dx equals 0. If y equals a sin log x plus b cos log x, then differential equation of this solution without parameter a and b is, so what we are supposed to do is remove a and b and form a differential equation. So given is y equals a sin log x plus b cos log x. So first step is always differentiating with respect to x. So dy by dx will be a differentiation of sin is cos of log x into derivative of log x, which is 1 by x, plus similarly for this derivative of cos x is minus sin x, so minus b sin log x into derivative of log x, that is 1 by x. So taking x common and shifting it to LHS, we get x into dy by dx equals a cos log x minus b sin log x. Again derivating it with respect to x. So this will be, now this is in the form of u into v. So this will be x into derivative of u, that is d2y by dx square, plus v into derivative of u, that is dy by dx, equals same thing, similar thing. So minus a sin log x by x minus b cos of log x by x. Now we take 1 by x common similarly. So x into d2y by dx square plus dy by dx into equals minus 1 by x a sin log x plus b cos log x. Now if you notice, this term is similar, this term is equal to y. This term is equal to y, so we can substitute the whole term as y. So this is nothing but minus y by x. So we got this as minus y by x. So this will be, previous step was x into d2y by dx square plus dy by dx is equal to minus y by x. So shifting this term to LHS, this will be x square d2y by dx square plus x dy by dx equals minus y. So shifting everything to LHS, this will be x square d2y by dx square plus x dy by dx plus y equals 0, and thus we got the differential equation. And now we compare it with the options. So this is x square into d2y by dx square plus x dy by dx plus y equals 0. So the answer is option C. In this question, we have to find the differential equation of y equals mx plus 4 by m. So given is y equals mx plus 4 by m. So first step is always differentiate with respect to x. So this will be dy by dx. Differentiation of mx is just m plus 4 by m. So differentiation will be 0 since it is a constant. So dy by dx equals m. So we substitute m with dy by dx. So this will be y equals ms dy by dx. So x into dy by dx plus 4 by dy by dx. Multiplying throughout by dy by dx, we get y into dy by dx equals x into dy by dx the whole square plus 4, which is option A. Y into dy by dx equals x into dy by dx the whole square plus 4. Dy by dx is equal to xy plus y upon xy plus x. Then the solution of the differential equation is, so this is the differential equation, dy by dx equals xy plus y by xy plus x. We have to find the solution of this differential equation. So first we take y common from the numerator, that is y equals y into x plus 1, and x common from the denominator, that is x into y plus 1. This will be dy upon dx. So shifting y terms on one side and x terms on other side, this will be y plus 1 by y into dy. This will be equal to x plus 1 by x into dx. So now integrating both sides, we get so integration will be log of y plus log y plus x plus log, this is equal to x plus log x plus let a constant which is a log of a, that is c. So instead of c we are writing log of a. So taking log on both one side, shifting log terms on one side, we get log of y minus log of a minus log of x equals x minus y. So this can be written as by using law of logarithms. This will be written as log of y by ax, and this is equal to x minus a. Therefore we can say y is equal to ax into e raised to x minus y, which is option C. The general solution of the differential equation x plus y into dx plus x dy is equal to 0. So differential equation for the solution is we have to find the solution for this differential equation. So given differential equation is x plus y dx plus x dy equals 0. We simplify this, we get x plus y dx equals minus or we can say minus x plus y dx equals minus x plus x dy. So rearranging terms, we get dy by dx equals minus of x plus y by x. Now here we can put x in terms of y or y in terms of x, since there is an addition sign. So what we do is, now this is an implicit function, so what we do is put y equals vx, that is y by x equals v another variable, that is y equals vx. So differentiating this, we get dy by dx equals v plus x dv by dx using u into v rule for this one. So we substitute this in equation 1. We get dy by dx is v plus x dv by dx equals minus of x plus y is vx divided by x. Now if we take x common from the numerator, we get minus of 1 plus v divided by x into x. So x gets cancelled, we are left with minus 1 minus v. So this is equal to v plus x dv by dx is equal to y minus 1 minus v. So v plus x dv by dx was minus 1 minus v. So shuffling these terms, we get x dv by dx equals minus 1 minus v, that is equal to minus 1 minus 2v. So bringing v terms on one side and x terms on the other side, we get this is equal to minus of 1 plus 2v, that is. So we keep the negative sign in RHS. So this will be 1 by 1 plus 2v dv equals minus 1 by x dx. Now we integrate this. So integration gives us half log of 1 plus 2v, which is equal to minus log of x plus log, say, c1. Let this be constant. So using law of logarithm, we get log of 1 plus half log of 1 plus 2v equals log of c1 by x using law of logarithm, that is log of a minus b is log of a by b. So we bring this term to RHS, so we get log of 1 plus 2. Now we resubstitute y equals v equals y by x here. Since we don't need v, we instead need x and y. So we resubstitute v as y by x. So 2 into y by x equals 2 into log of c1 by x. So if logs are equal, the inner terms are equal. So we can say therefore 1 plus 2 into y by x equals c1 by x the whole square. Again, this was log of c1 by x square by again law of logarithm. So multiplying throughout by x square, we get x square plus 2xy equals c1 square. Let this be c, another constant. So the final answer is x square plus 2xy equals c, which is option C, x square plus 2xy equals c. Solution of the differential equation dy by dx plus ay equals e raised to mx is. So we'll be solving this using integrating factor method. So if, that is integration factor, is equal to e raised to integral p dx. This is in the form of dy by dx plus py equals q. So integrating factor is integral of p dx, which is equal to e raised to integration of a dx. Integration of a is ax, so this will be e raised to ax. If is e raised to ax. So solution is y into e raised to ax, that is integrating factor, is equal to integration of q, that is e raised to mx, into if e raised to x into dx plus c. So this can be written as e raised to mx plus ax dx plus c using law of indices. So this will be e raised to m plus a into x dx plus c. So integrating this, we get e raised to mx, since e raised to, okay, so solution will be integration of e raised to x is e raised to x. So integration of e raised to kx will be e raised to kx divided by k. So in this case it will be e raised to, integration will be integration e raised to m plus a into x divided by m plus a plus c, that is constant. So this can be written as e raised to mx into e raised to ax upon m plus a plus c, and this is equal to y into e raised to ax. Now dividing throughout by e raised to ax, we get y is equal to e raised to mx upon m plus a plus c e raised to minus ax. So bringing this multiplying throughout by m plus a, we get y into a plus m is equal to e raised to mx plus c into a plus m into e raised to minus ax. So this is option D, a plus m into y e raised to mx plus c into a plus m into e raised to minus ax. Given differential equation is dy by dx plus 2y tan x equals sin x. So this is in the form of dy by dx plus py equals q, where p is 2 tan x and q is sin x. So integrating factor is e raised to integral p dx, that is e raised to integral 2 tan x dx. So integration of tan x is log of sec x. This would be e raised to 2 log sec x dx. Sorry, just sec x. So this will be equal to, now by law of logarithm, this will be equal to log of sec x square. Now by law of indices again, e raised to log of m to the base m is equal to m. So integrating factor will be equal to sec square x. So the solution is y into integrating factor, that is sec square x, equals integration of q, that is sin x, into integrating factor x dx into dx plus c. So integrating this, we get y into sec square x equals, now converting everything into sin and cos, we get sin x upon cos x into 1 by cos x, since sec x is 1 by cos x. So this is integration of tan x into sec x dx plus c. So integration of sec x tan x is sec x and plus c, y into sec square x. So the answer is B, y into sec square x equals sec x plus c.